in example 2b, we are trying to solve the equation 5 raised to the 2x power plus 3 times 5 raised to the x power is equal to 28. This is an exponential equation. You see the variable x in this term. The x is located, in the power, and the x is also located in the exponent in this piece, okay? So you can start by trying to move terms around so that you either end up with one exponential term on the left side of the equation and just a number on the right side of the equation, or you might try moving things around so you end up with one exponential term on the left side of the equation and then a different exponential term on the right side of the equation. As much as you try to do that, it's not going to work out. You're not going to be able to get this equation in one of those two formats, okay? This is actually another exponential equation that is quadratic in form, okay? So let's go ahead and take a look at it to see why that is. The first thing I'm going to do is move everything to one side because you kind of have to have your equation that way in order to work with something quadratic. The easiest thing to do is to just move the 28 to the left side. So I'm going to go ahead and subtract it from both sides. Okay, so now I'm going to end up with 5 raised to the 2x power plus 3 times 5 to the x power minus 28 is equal to 0. Okay, so let's focus on this first term where we have 5 raised to the 2x power. We can rewrite this term as 5 to the x times 5 to the x. Okay, again, this is a power of 5 times another power of 5. So by the laws of exponents, we can combine these two guys into one exponential term with base 5. We just would add the exponents here. So x plus x gives us 2x in the exponent. Okay, so the point of showing you this was to demonstrate that you can rewrite 5 raised to the 2x power as 5 to the x times 5 to the x. Okay, these two guys are equivalent. Okay, I'm going to jot down the rest of the equation here. And then in our next step, okay, remember if you have 5 to the x power times 5 to the x power, you're multiplying the quantity 5 to the x by itself. So if you multiply anything by itself, you're really squaring it. Okay, so this is another way we can write this term. Okay, and I'm just going to carry the rest of the equation down. Okay, and now if I make the u substitution, I'm going to let u be 5 to the x, the exponential piece, okay? Because you see 5 to the x here, and you see 5 to the x here, okay? So now I'm going to rewrite this equation, okay, where I left off. I'm going to rewrite it as an equation that only has u's. I'm saying goodbye to the x's here, okay? So if we start from the left here, 5 to the x, that's the same thing as u, okay, because I'm calling u 5 to the x, okay, so it's going to be u squared plus 3 times u minus 28 is equal to 0, okay? So we have gotten rid of the x's for a few minutes, okay? This equation, u squared plus 3u minus 28 is equal to 0. It is not exponential, okay? It's a regular old quadratic equation that we know how to solve, okay? One side is already 0. We can either factor the non-zero or apply the quadratic formula so that we can solve for u. Okay, so again, this should be pretty easy to factor, okay, but again, feel free to apply the quadratic formula. I'm going to factor the non-zero side, okay. U squared is going to break down into u times u. I need two numbers that multiply to be -7, or sorry, they need to multiply to be -28, the constant, and they need to add up to +3, okay. And the two numbers that do that are going to be 7 and -4. Okay, so this should factor into u plus 7 and u minus 4. And if you distribute, if you FOIL this out, okay, you can check yourself that you do get what you started with, u squared plus 3u minus 28. Okay, so we have factored the non-zero side. We need to take each factor, each of the guys that we're multiplying together here, set them equal to 0 and solve. So we're going to get u plus 7 is equal to 0, u minus 4 is equal to 0. If we solve u plus 7 is equal to 0 for u, just subtract 7 from both sides, we're going to get that u is equal to negative 7. And then if we do the same thing to the other equation, u minus 4 is equal to 0, we're going to add 4 to both sides. That's going to tell us that u is equal to 4. Okay? Remember, do not stop here. Yes, we solved the equation for u. But at the end of the day, our goal is to solve the original equation. 5 to the 2x power plus 3 times 5 to the x is equal to 28. We need the value of x. That makes this a true statement, not the value of u. Okay, but this is the process we have to go through to get there. Okay, once we have solved for u, we need to return these equations to x. Okay, so again, we made the substitution that u is 5 to the x power. Okay, so now we're going to go to these two equations, these u equations that we've come up with, and we're going to say what u is. U is the same thing as 5 to the x. So 5 to the x is going to equal negative 7 for this first equation. Okay, and then for the second equation, u is the same thing as 5 to the x. So we're going to get that 5 to the x is equal to 4. Okay, so now we end up with two exponential equations, okay, because in both of these, x appears in the power, okay, but these exponential equations are much simpler than the original blue equation that we started with, okay? So we need to solve for each of these guys, and that will give us the value of x that works, okay? Let's start with the first equation, okay? We've got 5 to the x is equal to negative 7, okay? So 5 to the x is the exponential term. It is isolated on one side, so we can proceed to taking the logarithm of both sides. Okay, again, it's your call here. The base is 5, so it doesn't really matter if you use ln or if you use log. I'll go ahead and use log. Okay, so I'm going to take the log of both sides. Okay, as soon as you do this, okay, you should realize this is a mistake. Okay, because yeah, you can keep going and not really pay attention to what's happening on the right side. You know, you would bring the x down, but if you look at the right side, you've got the logarithm of a negative number. Okay, so if you actually, you know, forgot and you got to your calculator and you hit log of negative 7, you can't take the logarithm of a negative number. Okay, so this first equation, 5 to the x power is equal to negative 7, is going to produce no solution. Okay, that doesn't mean the original equation has no solution. Okay, just this first equation, 5 to the x power is equal to negative 7, it has no solution. Okay, we still need to see if the second equation, 5 to the x power is equal to 4, we need to see if that gives us a solution. Okay, so let's try to solve it. Okay, again, 5 to the x is the exponential term. It's isolated. I'm going to go ahead and take the log of both sides. So I get the log of 5 to the x is equal to the log of 4. All right. This one looks like it's going to work out because we're taking the logarithm of a positive number. Okay, on the left, we've got the logarithm of something to a power. We're going to bring our power down. Okay, so we're going to get x times the log of 5. On the left side, okay, that's got to equal the log of 4. Okay, so we're almost there. We've got to get x by itself. Luckily, it's come out of the power, so it's going to be easier to solve for. X is being multiplied by the log of 5, which is just a nasty decimal. So we need to divide both sides by this quantity. Okay, so then on the left side, these two pieces will cancel. The log of 5 will cancel both in the top and the bottom. Okay, that tells us the answer right here. The x value, that is the solution. There's only going to be one solution. It is the log of 4 divided by the log of 5. Okay, that's your answer. Okay, I'm out of room over here, so I'm going to come over here at the top and write the answer. Okay, x has to be the log of 4 divided by the log of 5. Okay, you cannot combine those guys into one logarithm. Can't do that. Okay, it's got to stay like this. If we go get our decimal approximation, we have to do the log of 4 divided by the log of 5. Okay, and we will round this to the nearest thousandth to get 0.861. Okay. All right, so here is your final answer. Okay, I'm going to go ahead and box this. Okay. This is the only solution to the original equation here. Okay. This is the only value of x that makes it a true statement.